Alright, let's look at the C++ implementation. The first thing we're going to do is we're going to create a function, and inside that function we're going to take in 4 variables. The first 2 are going to be the variables for our edges. These are arrays of vectors. The first one will store just the names of the neighbors, the next one will store the distances. What I mean by that is that v2, for example, is a vector, which is basically an array. So v2 is an array that stores the indexes for the neighbors for node number 2, and d2 stores the respective distances. So v2 of 3, for example, would have the name of the third neighbor for node number 2, and d23 would have the weight of that edge connecting them. The other thing we're going to use is we're going to use an array, and we're going to assume that everything in that array was already initialized as infinity. This is where we'll be storing our answers, and of course the name of the starting node. Now, let's look at something interesting. We're going to initialize a set of pairs. What is that? Let's call it set pair. What is a set of pairs? A set is essentially just an array that automatically remains sorted, and we can do everything with it: insertion, lookup, deletion in log n time. And a pair is just 2 integers attached together. It could also not be integers, but in this case it's integers. The set will keep them sorted by the first element of the pair. So if, for example, I insert this pair in my set, this pair in my set, and this pair in my set, the set will automatically order them like this. 0, 5 will come first, 1, 2 will come second, and 3, 1 will come third. And when we erase the first element, this is what we'll be erasing, the first one always, the one with the smallest distance. Now we're going to add to our set pair and to our answers array the first node. So the answer of the first node, the starting node, is 0. And of course, in our set pair, we're going to insert a new pair of 0 and the starting node's index. 0 is its distance from itself, and start is, of course, its name. Now let's move on to our main loop. And we're going to run this loop for every element in our set pair. So while our set pair is not empty. The first thing we're going to do is extract the first element of our set. So it's once again a pair of integers. We're gonna call it me. This should be a comma. And it's going to be equal to set pair dot begin. For those of you that don't know what this little thing is, essentially set pair dot begin isn't an actual pair, it's the index to it. This means give me the contents inside that index. Okay, or rather a pointer, better for the memory. If you don't know what that means, don't worry about it, just know that this little asterisk here is important. Now that we've copied it, we should also remove it from our set. So set pair dot erase, set pair dot begin. So back in this example, what we would do is we take this element out of the set and we remove it. This is what we've done essentially. Let's give some better names for our first part. My index will be the second part of the pair, and our distance is the first part of the pair. Now it's time to start trying to relax the edges of the node we're looking at. With this one, we have successfully extracted the first node from the pair. So, for this is it. Once again, a reminder, v of my index is a vector or an array, once again, same thing, that contains the neighbors of v. So we're going to iterate for every neighbor to node my index, so to speak. Alright, the name of the neighbor will be, of course, this one, and the distance, the new distance we'll be trying to relax it with, is the same thing, but with d, because that's where we restore the distances, plus the distance of the node that we've just extracted from the set. Now there are two cases we will look at. The first one is if the best known distance to that node was infinity, in which case we will be updating that distance to the new distance, and we will be adding it to our set pair. So dot insert a new pair with, of course, the new distance as the first element and the name of the neighbor as the second element in the pair. And that's it if it's infinity. We will also do the same thing if the answer of our neighbor is not infinity, but it's bigger than the new distance. So we're going to copy this code and paste it. But we also need to add another thing. In this case, if it's not the first time that we look the node neighbor, this means that at some point for Mr. Neighbor over here, at least this one, this if has run. This means that inside our set pair, there exists a pair with the neighbor. Here, we're adding a new pair with a new distance. But before we do that, we should also remove the old one. So we're going to erase set pair dot find make pair of course, the old distance, which is answer of neighbor, and of course the name of the target, neighbor. And that's it. This is Dijkstra's algorithm. Right, let's do some quick debugging here. This thing should be a comma. We need another parenthesis. Forgot the I here. And it's not a bug. An if would also work, but an else if is a bit more readable. Let's also add a quick main. We just declare our big data here. We read the number of nodes, the number of edges. We read each edge one by one. Then we set each answer to -1, which is what we chose to represent infinity with. We run our algorithm, and then we just print the answers. And that's it with pretty much everything. And of course, I compiled it. I manually inserted the example we looked at, and the answers are the same. In the future, we'll be using this same algorithm to solve a bit harder problems. Hope you enjoyed. Thanks for watching.